Okay, so in this video we're going to start discussing the idea of this fundamental theorem of algebra. It's really not knowing that that's the name is not a big deal. But what we're going to do here is we're going to put an equation together for what this problem says is a third degree polynomial. So this tells me right now that I have three factors, right? And that's kind of what this fundamental theorem of algebra is talking about. And we have a double root at -3 and another root at 2. Now there's this other piece here that we're going to talk about in a second. P of 0 is equal to 36, and our solution is going to be in factored form, so we don't have to distribute. But the idea here is, what I've underlined in blue is important because we have to understand that graphs change on based on some of the numbers that are put into them. So for example, kind of sideline here from this piece that we're talking about, if I had the graph 2 times x plus 4 versus x plus 4, they would cross at -4, but this graph would be steeper than this graph. Okay? So even though they cross at the same point, they are not the same graph. So if we take the initial description of the problem and we say we're going to write a third degree polynomial, it's got a double root at -3, so I know x is equal to -3 and -3, and we have 2. So then I'm going to work backwards, and I'm going to get x plus 3 times x plus 3 times x minus 2. Now, if I don't give you this piece of information, this P of 0 piece, this is going to be our answer, but that's all I can determine. But because of this, it tells me how stretched my graph is. So am I going to be something stretched like this or something stretched like that? All I know is the zeros. But there's going to be some number in front that's going to cause some sort of stretch to the graph. And it's going to adjust a few things. So how do I know how it's being stretched? Well, it's kind of set up pretty easy for us. I know P of 0 is equal to 36. So that means if P of 0 is equal to 36, when I plug in x equal to 0, y is going to equal 36. So I can actually just solve for a by understanding that if I take this a, I know I'm going to plug in 0 for x for all of these pieces. I know the solution is going to be 36, and that actually allows me to solve for the vertical stretch. So I'm going to go ahead and simplify it. This is a 3, a 3, a -2, 36, 9 times -2. I got -18. A is equal to 36. Divide out the -18. And what do we get here? We get our vertical stretch as a -2. Okay? So I plug that in. I want it in factored form. That's my solution. Now a couple things to understand. If we didn't do this piece here and pretend that this a was gone, we'd have a cubic function that ends positive. But because of this little last piece of information, really the graph that we have doesn't end positive, it ends negative, and it's stretched by a factor of 2. So those are the things that we have to consider, and so just by having what's in blue here doesn't mean I have the whole equation. I only have a piece of the picture. This a gives me the whole picture of our equation, and so I need to be using that to solve these problems and get the exact equation. And we leave it in factored form, makes it a little bit easier. I'll do more examples, so if this was a little difficult for you to understand, watch a couple more videos.